Cloud. All right, this is recording now. All right. Where is present? All right. I'll turn off the music. All right. Hi, everyone. Welcome to the Fall 2020 AI Competition Kickoff. Check-in code is AI Kickoff, but O is in 0 now. I'll give you guys a few seconds. If you don't know what the check-in code is for our membership portal. If you go to members.acmucc.com, you can log in, get points for our future merch store and other things. And yeah. I'm just going to introduce this real quick. This is our agenda. I'm going to give you a quick introduction, then give you a specs, which is basically explaining what the competition is, how does it work, how do you win. So first introduction, I don't really know what to call this. I just call it Energium AI competition. The idea is that it's a dawn of a new millennium. You can read the backstory on our GitHub page, but it's a dawn of a new millennium. You have these little units. You're an energy corporation, and you have these little collector units mining this resource called Energium on an asteroid belt. And your objective is to beat rival corporations that also happen on the same asteroids you're on, using JavaScript, Java, or Python to code your bots to mine this resource. So how does this work? You basically write any kind of code, a bot code to beat opposing bots on some objective. ML is not necessary. Like if you write a simple if statement, I'll show you guys a code in a minute of the sample bots I showed earlier. Basically, you don't even need ML to like win. Last season's winner didn't use ML. He used some complicated algorithms, but that's as complicated as it gets. Submitted bots compete on our leaderboard ranked using TrueScale, and explain what TrueScale is, and I'll explain how our leaderboard works. And this leaderboard is basically what we're using to do the final rankings. So JavaScript, Java, and Python are supported. So if you guys mostly will probably know at least one of these. You can use this to compete. So feel free to use any of these languages to compete. More can be supported if requested, but only if there's enough requests for it. I'll probably add it. Here's the specs. This is the most interesting part. So the objective of this game is to collect more Energium than your competitor. You want to generate more energy than your competitor. This is a pretty common thing to do. If you've done other AI competitions, it's always about just getting something more than the other guy. So here. So this is a quick GIF of a match in progress. So what can your bot do? Your bot can move these collector bots that are moving around the map, north, east, south, west, or sit still. You can't move off the map. And there's these little base points, these spawn points, where you can spawn more collectors by consuming Energium. You can also print error logs using the standard error. And I'll show you how to do this in the starter kits. Collectors, these are your collector units. They can move in cardinal directions once per turn. Depending on the tile they're on, they'll gain that much Energium on the tile. I'll show that in the future as well. And it auto gains this. You don't need to send a command to mine. These collectors also have a special thing called breakdown level. Your starter kits come with a function that returns the breakdown level, and it increases every 10 turns. Once the breakdown level reaches 10, the collector malfunctions and vanishes. So basically the bot breaks down and dies. And another thing is if two or more collectors collide, basically they move to the same tile on the map. The collectors with lowest breakdown survives and all other collectors break down. So this could be a potential strategy to eliminate the competition. And if it's a tie in terms of the lowest breakdown level, all collectors break down. Next up, bases. So these circle things are called bases. They can spawn new collectors for a cost of 50 Energium. They cannot be destroyed, they cannot be moved or made. Collectors also can reset their breakdown level to 0 if they move on top of a base. So effectively, they can repair themselves if you move back to that base tile. And if you don't know, this whole entire competition is grid-based. So you have a square map of n by n. I think the sizes are either 16, 12, 24, or 32. And yeah, any questions so far? Alrighty. So this is Energium collection. Can you repair another person's base? No. Are the grids randomized? So all these maps are procedurally generated. I can explain the algorithm if you want, but it's basically a Gaussian map plus convolutions. Energium collection. So this is the Energium collection. The way it works is that you actually, if you don't see the numbers like this is like a heat map. Where purple and dark to black represents Energium deficient tiles. and orangish and to dark orange are energy efficient or rich tiles. So collectors on a tile gain or lose energy depending on the tile's energy value. So if you're on a -1 tile, each turn you're on that tile, you lose -1 out of your total energy store. And collectors don't have their own store. It's a global store. So every time you gain one, it's added to your player's energy count. On the visualizer, which I'll show later, you can toggle the values overlay on the visualizer to get the exact values each tile gives. You can treat the colors like a heat map on the visualizer to see which tiles are good and which tiles are bad. For those of you who are just joining, this is an introduction to the Fall AI 2020 competition. If you feel like you missed anything, make sure to check our recording. I'll post the recording later in the Discord channel. So far, we're just explaining the specs, so you haven't missed too much. And again, the main objective is to collect as many resources as you can on this 2D grid map, namely Energium. All right, that's it for specs. Any other questions about specs? And no, Michael, you can't repair another person's base.
So if you get on step on an energy deficient tile, you will start losing energy for your team, right?
Sorry?
If you step on a purple tile, you will lose energy level for your own team, right?
Yeah, so you lose energy. I mean, Bryce has a good question. Yeah, these tiles don't deplete; they are constant. So as long as you're on it, you'll get +7, or as long as you're on it, get -1. These are constant tiles. I will say it's because Energium is special and that it doesn't lose energy. I don't know, this is bullshit. Yeah, what's the other question? Someone asked if you need any experience with AI. You don't need any experience with AI at all. I can literally say that all the previous competitors and winners have done it without using actual AI algorithms. At most, you might use a pathing algorithm, but those aren't too complicated. And I might give a workshop in the future about using BFS. But you don't even need a pathing algorithm for this competition. Like, I highly doubt it. It doesn't have to be complicated. Any other questions? Oh, and there's another question. When does the competition end? I think I set to end in 2.5 weeks. So this gives you guys ample time to develop strategies, write code. The last one we want is for you guys to have rush code in the sense that you might submit something bad and it doesn't work or something. How much coding experience do you need? CSE 11 is good enough. If you know the right if statements and for loops, which is all we're actually doing, it's fine. Yeah, once I show you the starter kits, you'll understand how simple it is, or mostly how simple it is. If you have any questions again, it takes no more than like a few questions to figure out what to do. Make sure to just ask us in our Discord channel. What else am I missing? Wow, this is so cool. Who made it? ACM AI. How long does match last? So there's 200 turns max. I forgot to mention this. There's 200 turns. I'll talk about computational times in a minute. Can you work as teams? Yes, you just need to submit as one account. Just let me know when you do your final submission, like who's in a team. Right now, we don't have an official team in the code. Just have one person submit the bot. Hello? Hi, Vadan. If you're asking a question, I can't quite hear. Do you mind typing it in or something? All right, next slide. Okay, now I'm gonna talk about getting started and how to develop a bot. Pretty simple. I want you guys to all follow along, kind of. First thing I want you guys to do is go to this website. You can find it by just going to our website and then clicking competitions and then Energium. So first, log in and register for ACM AI account. If you don't have one, make sure to make it. And if you're not from UCSD, also make it anyway. It's fine. Register into competition on the website above. So I'll take you guys through it real quick. So let's just say I register account, test bot 123. Let's just make an email at hbc.org. This is a fake email, but whatever. Let's do a random password here, register. Save that account, log in. Once you guys log in, go to the competitions, go to take me there, click register in competition. In about a second, it'll tell you register into competition and say good luck. All right, any questions? Andrew, the question is, if two collide, will the one of the lowest breakdowns still survive or will both? No, only one unit can be on a tile. Yeah, so you're gonna need, you're gonna have to have the lowest breakdown will survive. And if they have the same, if they're tied, they'll both die. So once you get a register, you can click upload bot. You can click leaderboard, you can upload bot. So I'm gonna show you the upload part now. So next step, go to our GitHub link, github.com/acmucsd/energm-ai-2020. Sorry for a long name, but yeah. So this is the thing. Oh shoot, wait. I just realized I didn't update something to readme. Oops. Someone just pointed out a bug, and that's because I put something wrong. Yeah, it should be file. All right. Back here. This is just a quick description, general getting started, and specs. All right. What did I say in instructions? So first, I want you guys to all download a kit of your choice. So it can be JavaScript, Python, or Java. I'm going to download a JavaScript one, and I'm going to download a Python one for demonstration. All right. I don't know if my computer has Java, so I don't know if it works. I know my Docker image works, but yeah. Now let's do kits. Download the visualizer. You're going to need this in order to watch matches, because also the watch replays button on here is not an online thing. It requires you to run it. So let's first actually, let's go download this. Really easy, simple zip file. Now we're gonna do, make sure you have, and also this is another thing. I'm sorry for all Windows supported users, but you're gonna need something called WSL, which should not be too hard to add. It's basically called Windows Subsystem Linux. And you're also gonna make sure you have Node.js 12.x or above. If you have any issues installing any of those, consult anyone in the board in the AI channel or Discord competition channel. And there's instructions here provided kindly by Aaron from ACM about how to add WSL. Anyway, next steps. If anyone has any questions, feel free to stop me and ask. The first thing you want to do to install and start competing is do this. Once you have Node, you're going to have something called npm. So what you're going to do is go to your terminal. Sorry, just joined. Is it GitHub on Discord? I should probably post on a Discord. I thought I did. Nope, I did not. Thank you for reminding me that. All right. So first thing we're gonna do, simple. Let's just go to our desktop. I'm gonna do npm. Oops. I'm gonna do npm install -g at acmucsd/energm-2020. Click that. Yes, access my desktop folder. It will run something really funky looking. Ignore the messages. It'll take about less than a minute to install typically, unless you're on really bad Wi-Fi, then it might take longer. Once you install it, quickly, ooh, I should probably not have done it there. Okay, doesn't matter. To run a match is really easy. So do ACM AI-energm, and you provide the two paths to two bot files. So remember I downloaded the Python kit and the JavaScript kit. So they're in my downloads folder. So let's go navigate to that. So what I'm gonna do is I'm gonna go to downloads, JS kit, and bot.js. So that's bot.js, bot.py, or bot.java is your main bot file. That's the file you use to pass in to submit bots, basically. I'm gonna pass the other bot. And what is it, bot.py? There we go. It will run really quickly. And it'll output you some nice messages. So here it'll tell you, while it's running, it'll tell you some warnings. Some warnings include if your units collide each other, if your unit tries to go off the map, etc. And then it'll output the results. So there's the rankings, stats, how many points you gained. Points is actually Energium. It should be renamed, but it's just called that. Terminated is whether or not your bot failed or not. But once you run this, you're gonna see there's a replay file. So if you go here, ls replays, you'll see there's a new replay file in my desktop. So let me go to my desktop. Here's the file. It's a JSON file. It's very simple. Just a note, replays online on the website will be stored in a compressed format, but the ones you run locally will be JSON. And if you want more configurations, simply type this to see what else you can do with this command line tool. For example, we can provide a seed. All matches are seeded. We can suppress logs, give a max computation time, et cetera, et cetera. All right, so let's see how we watch this match. So what you're gonna do is you're gonna take your visualizer folder, right? I got this here. I'm gonna open it, and then I'm gonna go to my command line. I'm gonna go navigate to my visualizer. Slides are posted on the GitHub page. Just go check that out. Once I go to the visualizer, simple as this: do npm I or install. Take like less than a second, and then all you have to do is do npm serve. You're done. It will run a website on your local server. Just copy the link, go here, and you'll get your visualizer. And now to watch a match we just ran, click upload replay, navigate to the replay, and upload the file. All right, and now you can get this. So this is like a tiny 16 by 16 map. Let me go figure out what else I was gonna say. Okay, I'm gonna quickly take you guys through the visualizer now. And after taking you guys through this, I'll tell you guys how to submit bots. I wonder if anyone submitted anything yet. Probably not. It's way too early. Someone already tried running code. Okay. So this is just a visualizer. You can click this to toggle that value overlay to see how many points you get per turn on each of the tiles. You can press play for it to run live. So run turn by turn. You can increase speed, like 16x if you want. You'll see these guys moving around randomly. That's your starter kit. It basically just moves randomly. You can check the side for how much energy you have or points, number of units you have, and you can also click on tiles to get information about the unit. So you see this unit here has a breakdown level of 7. It was last repaired on turn 126 at tile 85. You'll also see that the other bot actually malfunctioned and broke down, and you can probably see why here. Actually, why did it break down? Team unit 0 collided at 4. Oh, nice. Okay, so you see this. You see that this bot has a breakdown level of 6, but this bot has a breakdown level of 1. So if they both move to the same tile here, the bot with a lower breakdown is going to survive. Any questions so far? Okay, the final thing about a visualizer, in order to watch matches online, so let's say you go to your profile, you can click watch replay on matches you've run. You have to click watch replay, but you have to make sure your visualizer is running. So remember to run npm run serve to launch your visualizer. So you click that. And also, if you forget the instructions, all the instructions are on GitHub. So if you click npm run serve, it will automatically download the replay file and open it and then run it. It just takes a little bit of time depending on how big the map is and how many commands there are. And I think my computer's lagging a little bit. There we go, just loaded. It also tells you which team won, so Breadbot won here. Let's just play at 8x, you can see it unfold. So you see Breadbot going to some high energy tiles, went to this one here, collecting points here, building more units, etc. Are all matches one bot vs one bot? Yeah. They could have been 4 for all. The only issue with that is a little bit computational intensive, and 2, typically 1v1v1v1 matches aren't well balanced. Is this mini StarCraft? Maybe, but like a lot less units. When do you have to have these coded by? We're gonna use whichever submission you submitted last by next week. I'll put the final deadline. I'm actually not sure when the final deadline is. I'll announce it a little bit later. What information does your bot have access to? Good question. I'm gonna get to that very soon. Give me a second. Let me just close this. Unfortunately, my computer can't run Zoom and other things at the same time, so I'm gonna close this as well. Let's get back to this. So this is just that. I'm gonna first show you guys how to submit a bot to a competition. Very simple. Submissions never hurt, so submit as much as you like. Our final rankings are gonna be determined by whichever submission you submitted last. In order to submit a bot, you have to zip up the contents of your folder. Oh, PPT is on our GitHub. So on Mac, it's really easy. So let's go back to our bot. We download it. So look at our, let's look at our Python kit. All you have to do is on Mac, just select both of them, click compress. Once you do that, you have an archive file, you can submit that. If you're more tech savvy, you can use the terminal. So let's go to our Python kit. What we're gonna do is we're gonna do something called zip-r, give it a name bot.zip, and do dot. This will zip all the files up into a file called bot.zip. All you have to do now is go to the website, go to here. This link is everywhere to upload bot sync. And also, in order to upload a bot, you're gonna need to be logged into ACM AI, the website, and you need to have registered in competition. If you haven't registered, basically this link here will be a register link, which I showed earlier. So upload bot, give it a name. So I'm called test123. I'm gonna upload a zip file. Let's go find it in our downloads folder, bot.zip. Here's the other thing that's sometimes a little bit confusing. You need to provide a path to your main bot file. So in all the starter kits, there'll be a main bot file called bot.py, bot.js, or bot.java. Provide the path to that file. So in here, it's just gonna be bot.py because bot.py is a file, and consider your folder that you zipped up, your root folder. Bot.py is the path to provide. Yeah. And also, just if anyone has any questions about this, you can use multiple files. Like here, I have a lot of other files. This NGM folder, you should probably not touch. This is for running the bot. Otherwise, you can put as many files as you want. So I'm going to submit the bot. It's going to give me a nice message to selectively upload a bot. I'm going to check the leaderboard now. And you see this bot is up here now. Has run 0 matches, starting score of 25 mu, sigma of 8.3. If you don't know what these numbers mean, I'll explain them in a minute. This is how ranking works. But if you refresh this list, you'll see that this bot will start to slowly run matches. Give us maybe another second. There we go. First match ran. It just played against that Breadbot and lost, unsurprisingly. Breadbot is superior. And yeah, you can watch a match. And also, just to distinguish these things, ACM AI has its own account system. So the acmucc.com membership portal is a different account than the competition account. We don't have them synced up, unfortunately. So here we just played our first match. Let's see what happened. We lost, actually. It tells us we lost. And here's the match. Play, you'll see that test 123 is kind of stupid. It's kind of running. Oh, it just crashed. Okay, it just crashed into the other guy. But this is a strategy. Crash into the opponents is actually a good strategy. Anyway, here's all the couple things about the website. Okay, this link should not work, actually. I don't know what this link's for. That doesn't do anything. You can click the players link to see the profiles of other players and watch the matches of other players. So you can click a top bot like my bot, which is currently top. See all the matches of winning, see the strategies, copy the strategies. I don't care. Yeah, it doesn't work on Windows right now. And also just logs. So if you look at this, this will tell you all the logs. At the moment, all the bots have no logs posted, but I'll actually show you an example in a minute. You can see both bots' logs. And also, if your bot fails for some reason, for example, if you're using a Java bot, there'll be a compilation step where we use Java C. If your bot doesn't compile, we automatically disable your bot, and you can check your error logs to see why it got disabled. I won't show that. It should be pretty obvious when you check the error log. Basically, it'll be your top result, and it'll just say error. Doesn't matter how much energy you get, or doesn't matter if you get more than other bot. It matters that you get more than other bot. So every match, there's 2 bots fighting, two competitors, your code and someone else's code. Whoever gets the most points or energy at the end of the match wins. I'm definitely sure I missed a bunch of other questions. Will there be AI competition fall quarter, or is it roughly 1 per quarter? There's another one for neural networks this fall quarter. This is based on our neural network workshops. So for UCSC students, we're hosting a small modeling competition where we're gonna give you a random set of data points and you're just gonna try to model it using a neural network. But that's a little bit after. There's also 2 more AI competitions coming winter quarter. There's a reinforcement learning one, and there's another one of this kind. Yep. Okay, next. Does anyone have any questions about submissions? All right. There's more instructions in each of the starter kits in the README, or not the README, sorry, in the bot.py file. It'll give you some comments. No, Matei doesn't work anymore. I used Docker this time. Oh wait, I think.
I mean, does the competition just end when there's no bots left in the game?
Oh no, I think it
No
keeps going.
eclipses?
A match ends when 200 turns is reached, or one of the bots fails. Like a reason why
When the
your
bot crashes all, like I mean the program crashes all.
Yeah, if your program
I
crashes, you effectively terminate it and you'll lose.
Yeah, okay.
Okay, and so here's a couple other comments about, I didn't add this. I should probably add this somewhere. I'm gonna make a slide. Give me a second. Limits. So you're given all bots have 1 second to make all computations before it loses per turn. So the bot goes to a place where it gets more points and brings them back somewhere. No, it doesn't need to bring them back anywhere. Halite does that where you have to bring it back. In this competition, you don't. If you mine Energium, it gets automatically teleported to your company battleship or spaceship, and then you just gain that Energium. The only reason why you want to go back to your own friendly base is to repair your bot. It has 100 turns, actually. So every 10 turns, its breakdown levels increases by 1. It's not moving allowed. Yeah, if you don't send any proper commands, or if you don't send commands to the match engine, you won't move. Yeah, you have 1 second to make all computations, and you also have about 1 GB of RAM. Even if it doesn't move, yeah. So every turn, we increment. So every 10 turns, we increment your breakdown level by 1. Once it reaches 10, we're gonna eliminate your bot. All right. So these are just a couple limits. Goals to maximize energy while ensuring that the bot does not break down. You can let all your bots break down. The only goal is to maximize Energium. That's it. Whoever has the most Energium by the end of the match wins. If you have no collector units left, but somehow have more Energium, you'll still win. Because at the end, these bots don't matter. They don't have lives. Bots' lives don't matter. Energy ladders. No, bot lives matter. Yell them. Are the maps randomized? Yes, they are procedurally generated. And if you're on tile for a given turn, you get the energy on that tile? Yes. Okay, I'll answer more questions after. I'm gonna go through the rest of the slides. And the symmetry thing's still around. Yes, there's diagonal symmetry, vertical or horizontal. Okay, I definitely forgot to say something. Oh, I'm gonna show you the code. Right, okay. Go to the screen. Let me go show you guys what the code looks like. Okay, do you guys want Python, JavaScript, Java? I think Python's probably preferred. All right. The thing is, like, a lot of people are learning Java because CSE 11 or CSE 8B. I feel like Bryce is joking. Okay, anyway, regardless of which language you use, it looks the same. The API is basically almost the same. Wait, CSE does Python now? Oh. Okay, anyway, so this is your bot. All your bot files, you know what, I'll just open both Java and Py. You know what? I'm pretty sure no one's gonna use JavaScript. It's only me. PowerShell works. You can code in Bash if you want. All right, so this is what it is. You on your bot main file, you have a while true statement. Do not touch this. This is where every turn happens. So what we're gonna do, you're gonna call something called agent.update. Don't touch this as well. It'll increment your turn and receive all updates from the match engine. Don't touch this array as well. Commands, you need this in order to send commands. Don't touch anything here, basically. This is all for a framework. But here are some variables that are available for you. So you're gonna have a player object and an opponent object, which are both of type player. Basically, in your player, you're gonna have details like this. You're gonna have bases, which is the list of all your bases. Energium, how much your team's Energium has. Your team ID. You can use it to check if the unit is yours or not yours. And units, a list of all of your owned units. So it won't include your opponent units. Same API for Python, although there's no type hinting here for some reason. How do you repair ships? They're not ships, they're little bots, robots, but you have to send a ship or robot back to your base. I'll answer that question again later. You basically have four. You basically have 1, 2, or maybe 4 set home bases. Here's an important part. You're going to need this. So this right here is printing. You cannot print to standard out. You need to use file equals sys.adhere, or if you're using Java, use system.error.println. If you can't there bases, your bot is gonna die. Anyway, if you use system.error, it will print out the error into the error log. So let's say we want to print the current turn using agent.turn, get our team ID, get the number of bases we have, number of units we have. And let's run a match. Oh, I can tab this. Okay. Python. And also, whenever you run a match, it will automatically create a folder called replays and error logs where it stores all your replays by time of running. Okay, anyway, let's go run a Python bot and let's see what they output. Also, here we go. So when you run the bot, it will output to your terminal what the bot said. So this is exactly what we're outputting. So forth and so forth, and you can check error logs. So here's our error logs for the first agent, here's our error logs for the second agent. This will also include any errors you have. So if you have some like runtime error, it'll pop up in here as well. Here's your replay. As usual, you can just upload this. Any questions about logging into debugging? This is your only way to debug it, by the way. And same with Java, you can just do system.error.println. All right, cool. So I'm just going to take you through basic bot code of how it works and what you can do. So in Java, JavaScript, and Python, you have a game constants file. ACM AI server. We have a competition Discord. I recommend you answer that in there. That Discord I'll show in a minute. But yeah, this is a lot. I'm sorry. For first timers, this seems like a lot, but it's actually pretty simple once you just get the starter kit, because really all you have to do is just look at this one file. Anyway, here's a quick couple things. So this is what we do. The starter kit bot basically checks how many units you have right now. If we don't have 4 units and we have enough energy, more than the unit cost, we're gonna take our first base and try to spawn a unit. The way commands work is you have to push the spawn unit's return value to commands. The only commands you have is spawn unit and move. So if you don't know how to use the commands and submit them to the match engine, just copy what's in the starter kit. Then after that, what we're gonna do is we're gonna iterate through all our units. For unit in my units, in Java, we just do for a loop here. And first thing we do is we check our breakdown level. So this is another function given to you, get breakdown level. If it is greater than the breakdown max, which is basically 10 minus 2, what we're going to force our bot to do is first we're going to take a direction to our home base, and we're going to move there. So here's, I'm going to explain the move API. So the way you move is you use the direction. Direction is a constant. There's directions like east, north, west, and south. Thank you, Bryce. So there's also another API, position. There's a thing called position class. Here, it gives you a lot of helpful functions. So is adjacent tells you if it's adjacent to another position. Translate translates a position by some number of units in a direction. Distance gives you Euclidean distance. Direction 2 gives you the direction from this position to another position. This is just a simple pathing function you can use. You don't need to use it, but you can use it as a start. So for example, here we're taking our current unit position. We're going to find a direction to a random base, our first base, the position of the first base, get that direction, store into direction back to base, and we're going to append it and we're going to make it move there. This is so units are about to break down, we send it back home. Any questions about the syntax or how this works? If you're worried about types, use Java. This is Java typing here. I don't know what Pyrite is. Yes, TypeScript. Oh, we don't have TypeScript support. I couldn't be bothered to write it. Oh yeah, the Python thing has type hints. I think I added them. It's just not showing in my editor. Yeah, if you're on a Discord, you can feel free to use the general channel, discussion channel, any of the channels to ask questions. I will literally always be there to answer you. All right, no further questions, let's move on. What's the next bit of code? So for a starter kit, something you can do really easily, as an example, is move in a random direction. So let's take all of our directions. This array of directions is 4 directions. Choose a random direction. So this is, if you don't know what this map does, all it does is just choose a random index. Gives you a random direction, and then what we're going to do is first we're going to use the translate function. The reason is because you want to check if this new position we're moving to is within the map. So in order to translate a position to another position, like on a Cartesian grid, just take a position, unit.pos, translate it by a certain direction, and give it a number of units. Yes, you're given entire board information. I'll explain all the information in a second. I'm just gonna go through the rest of the code. So new position.x is greater than or equal to 0, smaller than agent.map list, greater than y0, and so forth. Just checks if it's inside the map. After we check if the position is valid and can go inside the map, all we do is now, as a simple rule, we don't move if the tile we're about to move to has less than 0 energy. Does that make sense? Basically, if I go to this new position in the random direction, I will lose points. So we obviously don't want that because we want to maximize energy. So we're just going to pass. But if the random direction we chose to move to has greater than or equal to 0 energy, let's feel free to move it. Maybe we'll get some energy collected. Any questions?
Oh, so what Python version the bot using on the server?
I think 3.8.5. I'll show. It's on the GitHub at the very bottom.
Oh, it's a Docker image, right? Okay.
Is this individual team comp? I don't care. You can work with as many people as you want. I just ask that you don't share code with other teams. Colab work as an environment. Does it export files into Python? And I don't know. I've not used Google Colab before, really. Yeah, so you can export in Python. If you want to run a match, you're still going to use the terminal. So that's where it might fall short. Let's see. Yeah, okay. Now so this is the rest of the code. Don't touch this as well. This submits the commands to the engine using standard out, and this tells engine our turn is done. And here's another note. Remember that you have 1 second computation, 1 GB of RAM. If at any point between update and end turn, you take more than 1 second, your agent is going to be terminated and you lose. So you get 0 points and you automatically forfeit the match. If both agents terminate for whatever reason at the same time, both agents lose and it's just a tie. And yeah, there's ties in this game. All right, here's all the information you guys have. Where's the next thing? Oh, this is improvements, okay. So in this game, it's completely 100% vision. You see every part of the board. You know where everything is. Everything the opponent knows. Oh, I just went to semicolons here. Whoops. Okay, don't worry about that. You know everything your opponent knows. So let's just go through a couple of player objects that you have. So you have base. It contains details about the team, which is an integer, a team ID, and a position, which is a position type. It can also spawn unit, and this returns a string. That's the command to add. If you don't recall how to use spawn unit, just check the starter kit. Just do commands append unit.spawn unit or base.spawn unit. Unit. So all of your collector units are of a class unit. The same for Java and JavaScript. No, you can't spawn at any location. You can only spawn at the base locations. Do you automatically lose? No. You can have negative energy. So if the opponent somehow has a lot of collector units going on negative tiles, they might have less points than you. I don't care what happens. The only metric we're using is how much energy you have. How do you specify what base to spawn on? Good question, Aiden. All you have to do is here. So remember my bases or bases, player.bases is a list of all your bases. Let's just choose your first base in that list. We call spawn unit. No, if you spawn a unit, if you try to spawn it and you don't have enough energy, you get a warning and nothing happens. So this is a spawn unit command. Just call this in order to spawn a unit and append it to the commands list. And I'll always refer back to the starter kit for instructions. Here's a unit class. You have a team ID again, an ID for the unit, which is also an integer, position, a position type, a class. Elastic per turn, you don't need to worry about this. Match turn, you also don't need to worry about this. Get breakdown level tells you the current breakdown level of the unit. Do I have the visualizer open? Yeah, all documentation is in the files. It's in the starter kit. So if you go to bot.py, it basically tells you what everything does. So let's take a look at this. For example, details on the breakdown level. Oop. Okay. Why is this not showing? Okay, for some reason it's not showing details, but let's not ignore that. Move is a command to move a unit in some direction. Player is your player object, gives you a list of units you own, list of bases you own, your team ID, the amount of energy you have. That's mostly it. The last thing you guys should probably take a look at is the tile object. So tile object, you have a base team. This is set equal to none. So is base tells you this tile has a base on it. Yes, if you stand in one spot, you collect that tile's energy every turn. So tile is the type for everything that's in the map, in the game map. So you can get tile by position class, or you can get a tile by X and Y coordinates. This tile tells you how much energy is on the tile. If you recall, we checked this energy before. For example, we got a tile by using this function here. We call the energy field, and we see that it has less than 0 something. Pause is the position of the tile, and that's mostly it. Any questions about the API? No, there's no ML. You can use ML if you want, but you don't need to use it. Yeah, so next thing I'm going to show you guys, leaderboard. Is there a set of instructions somewhere? It's all in bot.py. It tells you here. This gives you instructions on what to do, like how this current code works. It also gives instructions about how to debug your bot and what available data is for you. The last thing, and I also give you some tips in here. If you have more questions, just ping me on Discord or anyone else. We'll tell you basically everything. So the last thing we talk about is the leaderboard. So I'm gonna skip this part first. We have a $100 prize pool. If you don't know, I got a random $100 raffle card, so I'm just raffling that out. $50 for first place, $35 for second, third, $15, and you guys all get posted onto our website. The way rankings work and decisions work is one day before finals, which I'll announce a little bit later. 1 day of matches will be run, and the final rankings on leaderboard will be used. Here's our leaderboard. So once you submit your bot will go onto a leaderboard. If you didn't see earlier, you can check in the recording. Testbot123, I just made this account. If you go to our leaderboard, you'll see that this bot went online after I submitted it. Currently ranked last because I submitted a really bad bot. But to watch matches, which I encourage you to really do, is go here. You can either download the replay and upload it to your visualizer, or watch replay to automatically download it onto your visualizer and run it. And I'll show you this example. And then you can analyze. So for example, here we won. Now the question is, why did we win? If you play it out, you'll see that our red bot touched those good energy tiles by accident, got some points, and we won. It'll play against bots of similar ranking. So your bot will most likely not play really high ranked bots because you'll probably lose. As an example, I can talk about the scheduling algorithm a little bit. It's not that complicated, and it's actually not that good. It could be improved, but it works fine. So if you're ranked first, you're probably going to play at most any rankings within plus or minus 5 of you, I think. So yeah, so don't worry about getting stuck or like anything. True skill is meant to accurately evaluate your skill. And we also use procedurally generated maps. So if your bot is robust, it's more likely to win, and it's less likely that you lose some matches by chance. Is this a full information game? Yes, you have all the details. We give you everything that you know and your opponent knows. So this is how a leaderboard works. Bots are ranked by score, which is calculated as mu here minus 3 times sigma. Mu is basically the measurement of your true skill. Sigma is our variance. How confident are we about your skill? If sigma is low, we're more confident. If sigma is high, we're less confident. Mu increases whenever you win a match, and it increases even more if you beat an opponent with a much higher mu. And it increases even more if your sigma is high. If your sigma is super low, your mu value is probably not going to change too much. Another thing, the sigma value decreases after each match you play. if you recall, if you saw earlier in the video today, when I uploaded a bot, test bot's sigma started at 8.3, which is actually 25 divided by 3. And its mu started at 5. So whenever you submit a new bot, your sigma starts at 8.33, gets reset, but your mu stays the same. So your first bot is going to start at 25 mu, that's your score. Every time you resubmit, your mu does not change, but your sigma gets reset. So this allows you to overtake top competitors. So let's say your first bot is really bad, your mu score is really low at 25. Let's say I submit a new bot that's really good. As an example, I'll submit a benchmark bot for test bot 1, 2, 3, and you'll see it climb the ranks really fast. Let's go to upload bot. And this benchmark bot is not available for you guys the same. This is my own code. This is benchmark. You'll see this bot start to climb in the ranks. We can check back this later. So you see sigma got replaced like 8, mu is 20 now. I think that was old mu. It's gonna start playing new matches. And you see instantly the mu is going up. When we check back, I'll bet you this test bot will be above benchmark. All right. Any questions about the scoring system, how the rankings work? If you guys are confused how to win or like how to do well, I'm gonna give you guys tips in a minute, just some good directions. And also, I'm probably going to try to document the Python code a bit more. The Java code should be fully documented. The Python code is a little bit less documented. I'm going to go update the zip a little bit later today. Any questions? What are people saying in Discord? Oh, has anyone tried the code yet? Like tried running a match? Has anyone had any issues? By any chance? All right. They're constantly held. The minute you submit your bot, it's going to run a match. Let's look at our radio board. I'll bet you test bot 1 to 3 is above. There we go. When you submit a new bot, it instantly goes up. Okay, I'm gonna go make a channel for team. Looking for teams. Someone just asked to make a team. Is there any sort of time limit for bot action inputs? Yeah, so you have 1 second, which is actually a lot of time. Just a relative measure. This bot here probably takes like 10 milliseconds to run, and it doesn't even do that a lot. Actually, probably even less than 10 milliseconds, maybe like 1 millisecond. Not a whole lot of time. Sorry, yeah, it takes very fast. And yeah, you see that when you submit a new bot, its new ranking will instantly be reflected. So I literally submitted a new benchmark bot, which is better than Starter Kit, which you guys don't get access to because that's my bot. And it's doing well now. And whenever you submit a bot, it's automatically submitted into our queue. We'll automatically schedule matches, and it will constantly be running matches throughout the 2.5 weeks. Computational resources available. 1 second limit, 1 second limit per turn, and about 1 GB of computation. In terms of CPU, you basically get 1 CPU. Kind of. I don't know how good the CPUs are, but they're not bad. Like I think they're about as fast as my MacBook Pro. It's on GCP. All right. Here's a quick thing. Make sure, as always, adhere to our rules. We want to treat everyone at ACM and the broader ACM community with respect. We accept and welcome people of all backgrounds and skill levels. Harassment, hate speech, verbal abuse are strictly prohibited and will result in an immediate ban from any competition, from this competition particularly. Any malicious hacks are strictly prohibited. Moreover, you may not submit bots that perform hacks on the competition. We don't condone malicious activity. This includes but is not limited to shutting down our servers, removing files, reading other people's code, unless you're given permission somehow. You're not allowed to open source your bot code until the conclusion of competition, as will be stated in the announcements. You may freely talk about it with other competitors, like the strategy and all that, but we ask you to, for integrity of the competition, that you don't share the exact code. All right, any other questions before I move on to like just what you guys can do next? I just talked a lot. All right. These are just some tips on how to improve your bot. Always submit a new bot. Like I encourage you right now for all of you guys submit a starter kit. See what happens. Like when you guys get the chance to, make sure to download all the files you need, submit a bot right away, and just see what happens. The best way to improve your bot is by learning from your mistakes or learning from past issues. And it's always okay to resubmit your old one. So like, let's say you submit a new bot, it's worse, just resubmit your old one. We'll use that for finals. If it's better, leave it up, right? And a good metric to determine how good your bot is doing, again, is using a leaderboard. Okay, wow, why is this bot doing better than Breadbot? That's not right. Okay. Anyway, if you just check the leaderboard, you'll see how good your bot is relatively to all your other competitors. Watch lots of replays to gain insight. Your own and other top ranked bots. So you can check your own values. You can check other bots. I encourage you guys to watch the top ones to see their strategies or guess at them. You can't see their code, but you can see what's happening. Focus on easy, improvable tasks first. For example, random movement is definitely not an optimal. Like if you randomly move onto a negative energy tile, it's probably bad, right? For example, I'll show you one bit of code you can improve. Food for thought. Is this optimal to do? Random direction? Probably not. Recommend you guys to change this line and do something better. Always also use debug using error logs. Feel free to print error logs and just print out variables like turn numbers, etc. Here are some ideas you guys can try as a first step. Avoid random movement, I just talked about. Clearly random movement doesn't work, as you see that the starter kit keeps losing. Collectors cost a lot initially. As a note, you guys always start with 50 energium, so you can produce one collector at the start. So they cost a lot, so you probably don't want to crash them at the start. 3, avoid negative energium tiles. It doesn't make sense to stand on them, you're just gonna lose it. The only time you ever want to go through one is maybe because there's a positive one that's really high that you have to go through negative tiles to get to. 4, make your collector move towards high energium tiles. I'll tell you this, the Breadbot that's beating all the starter kits, its only strategy is moving the units to a high energium tile. That's it. 5, here's a more advanced strategy. Try to effectively use base repairs to collide opponents' collectors without malfunctions. As you recall, if your collector unit had a repair more recent than another collector unit, your breakdown level is lower. That means you can collide into a collector that's an opponent's collector and destroy it. Yeah, there is simultaneous movement. So if one collector's here, one collector's here, they can swap places and no one collides. Good question. Yeah, otherwise than that, good luck. All the information is on our GitHub. The slides for today is also on GitHub. The Discord link is also on GitHub. Make sure to join our competition Discord. The competition Discord is also separate from ACM AI one, mostly because there's people outside ACM, UCSD that compete as well. So you want to separate it. That Discord will have more active announcements. The ACM AI Discord is also being active, but we'll have less announcements about the competition. Feel free to join the competitions Discord. You can find a team there, discuss strategies, just chill, get help on bugs, strategies, etc. Yeah, if your own collectors collide, same collision rules apply. Any other questions? All right, yeah, this is pretty much it. We have like 4 minutes before it ends. I'm gonna actually pause the recording now. Stop it.